enough to see things the way that customers see them, which is good. You know, I'm dumb enough to be able to do that. So in the past, I'd always used a tool like Front Page or whatever to do web pages. So one of the other things that's been going on that I've been exercising a lot is the issue of fonts on the web.
Right.
You know, way back in the beginning of the browser days, you know, I was here then. In 1995 we shifted into Explorer for the first time. And I came in 1995. And one of the first projects I did was to have Matthew Carter design for us 2 new fonts specifically for reading large amounts of text on the screen. These were Verdana and Georgia. The Internet Explorer guys came to us in 1995 when I was running the typography group.
Could I ask you something about
sure.
Verdana? How does the process of designing such a font look like?
Completely back to front. The traditional process of designing a font is you do drawings at high resolution.
Okay.
And then you create, if it's going to be a computer font, you eventually create screen bitmaps at the end. Right? What we did was started from a set of bitmaps that we wanted to see. What were the optimum screen bitmaps for a serif face and a sans serif
So you used
face?
small. Was it like small bitmaps already? Or
Pixel popping, yeah.
Okay.
I mean, the most important sizes were 9, 10,
yeah,
11 and 12 point,
it depends on the eye, right?
So you don't design, I mean, fonts are normally designed in design units. Adobe's Type 1, for example, uses a design unit of 1048. And TrueType uses a design, 1056, is it? Or 1012, I can't remember, but I know that TrueType uses a design grid of 2056, right? 2056. Or is it 2048? I forget the exact number. It's a huge, it's a big number anyway. Because fonts are normally designed as an equation and it's kind of entirely scalable. But that works for high resolution devices, but it doesn't work for the screen. Because what the problem is that when you try to rasterize an outline like that into the coarse pixels of the screen, you get all these jaggies and you get dropouts and all kinds of stuff. And that's what font hinting in TrueType was all about. Font hinting is a way of giving the rasterizer hints as to which pixels to turn on at certain sizes. You know, so there are instructions. People don't know that. The average core font in Windows, for example, ships with 25,000 lines of programming in it. It's not a data file only.
That's fascinating.
Yeah,
I didn't know that.
There'll be an instruction that might be as specific as at 10 point on a 96 ppi display in Times New Roman in the lowercase letter A, turn on this pixel. This specific pixel.
That's interesting.
It can be that specific.
It's like a rules engine, if you will.
Yeah, there are rules that are much broader.
Sure.
That kind of deal with things like harmonizing the capital height and the baseline and the X height and the baseline of all of the characters. Then there'll be rules that define the relationship between the regular version of a font and the bold version of a font. You know, but then, you know, right when the rubber meets the road and you get to the final version of the font, you might still have some problem. You know, there's rules inside the rasterizer for dropout control, for example. You know, a dropout will be where you might have a pixel, say in a letter N, and you've got the curve that comes out of the stem, and this pixel for some reason falls outside the boundaries and gets turned off. So there's a break in the letter N, and what you need is some way of telling the rasterizer to turn that one on. So dropout control will do that. And then there are manual things that you do because, you know, I mean, we need to go to the whiteboard here, guys. Oh! And my whiteboard probably won't clean because some of it's been on there for so long.
Hopefully there's no product secrets or anything
Nah,
else.
but you
dates
notice this drawing is almost set into my whiteboard. This is 9 point, 10 point, 11 point, 12 point, 13 point, 14
That's
point.
actually what
it's showing.
I love how the 11
said before, right?
Well, yeah, that's just what I was saying.
11 is a question mark. That's what makes me laugh.
So yeah, I should no.
Yeah. Oh, is that the 1/72nd of an inch?
No, this is 1 point equals a 72nd of an inch.
Right.
This is therefore 1 pixel equals what? Because you have no idea.
Yeah.
Right.
Exactly what we were talking about earlier on. You see, I think about these. I can't actually erase that from my whiteboard anymore. But I think it's permanently bonded in there. Anyway, the real issue you have is, say you have a letter M, and it should look like this. Great. But then you put it on a pixel grid. Because you have to rasterize it, you have to turn it into dots.
Right.
Of course.
Now, what happens? Well, this one looks like it doesn't fill the whole pixel. So we'll turn it off in any simple algorithm, rasterizing algorithm. So there would be the ones that would be turned off. This one would be turned off. That one would be turned off. That one would be turned off. And that one would be turned off. So there's what you're left with. Your letter M. This one would be turned on, but this one might be turned off. So there's the actual rasterization that you get. You get this pixel, and this pixel, and this one's blank. And that's what really simplistic rasterization would give you.
Sure.
So what you need to be able to do is tell the rasterizer things like, make sure that all the stems of your letter M are equal widths, right? So these will all be 1 pixel wide. Don't change any of them until the text is scaled to a size where you can change them all to 2 pixels wide.
Oh, so you'd like
Right.
to define a relationship between these 3 guys here?
Exactly. That these 3 guys are always equal. So there'll be a program.
Who decides that, right?
There'll be lines of code. There's a
What is this written in?
TrueType has an assembler type language.
In
an instruction
like
set.
in each font, there's like, you have some part of assembler. Like,
Yeah. There's a
Oh,
whole
you
bunch of-
never, you like, if you use C# or something and you say font, gave it the name and you use it, you never think about that, right?
Yeah, never.
Just it works, you know?
I never would have thought the
somebody-
fonts had that much level of code or coordination to make them look that nice.
When we created the first, the first core fonts for Windows, the first core TrueType fonts for Windows, Windows switched over switched over to TrueType, I think in 1991. Right? It was Windows 3.1 that we switched over from previous font system to TrueType, to scalable font format. And so Microsoft had to go and create new core fonts for Windows. These are Times New Roman, Arial and Courier, everybody knows them. But do you realise that it took 18 people about 36 months, a huge amount of investment,
Really?
and nobody had ever done this before. Nobody had ever hinted a font to that kind of quality.
Sure.
So it was a huge undertaking. Now, the thing is that I wasn't even working for Microsoft at the time. I was working for Aldus. In Europe. I'd helped to set up the European operations for Aldus Corporation, which was based in Seattle. And the day I fired up Windows 3.1 for the first time and saw the type on the screen, I called over the boss of the company, a guy called Derek Gray, and said, "Derek, you've got to look at this. These Microsoft guys have just blown right past the Macintosh." Because I was a Macintosh guy. That's how I started in computing. In 1984, I got my first Macintosh. This was about 1991, 92. I called over Derek. "You've got to look at this type on the screen. I've never seen anything this good." And what happened was they'd figured out how to do all this hinting and how to tie it into the TrueType rasterizer and so on. It was a huge investment in
Interesting.
making these fonts. And we've been doing that ever since. We are better at doing this than anybody on the planet. No question. A long way.
With starting with TrueTypes, you started to do the bitmap fonts and then scale them up and
No,
down?
no.
Or is
that
just with
that was
Verdana?
with Verdana and Georgia. With
So that's a new
TrueType,
approach, right?
yes. With TrueType initially we started with printer fonts because it was all about printing in those days.
Right.
So we had high resolution outlines, and then we had to hint the rasterizer, give hints to the rasterizer to tell it how to display the bitmaps.
Yeah.
Because you wanted scalable bitmaps. You didn't want. I mean, before that you used to have bitmaps. You'd have a 10-point bitmap and a 12-point bitmap.
So you had you had like the bitmaps for these font sizes that you have on your. Like
They were
10,
all
11, 12.
hard-coded per size.
Yeah, that was what it was like in the beginning. I can remember that. I can remember the days when I had my first Macintosh, and you had like a 10-point times bitmap font and a 12-point times